Welcome everyone. This is lecture 4 of data structures and algorithms. What I'm going to be doing at this point is taking a moment and reviewing everything we've talked about and adding a little bit of extra information, but mostly talking about what we've previously discussed. So to begin with, one of the things is system out print versus print line. As you can see here, if you're using system out print, you have to add a new line character, which is the \n. However, if you do system out print line, you don't need that \n. And then we talked a little bit about how to set up and initialize a scanner object, and then getting information using the scanner.nextInt, nextDouble, or nextLine to get corresponding ints, doubles, or the string. Remember. Semicolons must be placed at the end of statement lines, and curly brackets are used to define a function or a control flow structure, like ifs, loops, whiles, all of those fun things. And as a side note, I've had a couple of questions about scanners. If you need more information, feel free to check out the documentation on the Oracle page. Now, we talked about last time different types of loops. And the thing about loops is they all have a similar structure. You need to initialize them. Then from there, you need to have a condition on moving forward or not, updating to get to that condition, and how you end. 3 types of loops that we've looked at are the for loop, the while loop, and the do while loop. So to go over them a little bit, let's look at the for loop. You have some form of initialization, which is like int I is equal to 0. Then you have the condition, where usually I is less than the length of an array or something of that nature. And then you increment or decrement what you're initializing. So I++, I-, and stuff like that. For more information, again, see the previous lecture. And then once you have that for loop, inside is where you have all your statements to do whatever you want for that loop. The next thing is the while loop. So what matters here is when the condition is checked. So a while loop checks the condition first, and then it executes code. However, a do while loop executes code at least one time, and then checks the condition. A really good fun way of thinking about it is as such. Well, the while loop will check if there's the ground underneath it before moving forward, while Wile E. Coyote will keep running and then check the ground underneath it. That is the main difference between a while and a do while loop. And again, remember with while loops and do while loops to increment the counter so you're moving towards the condition to exit out. If you do not do that, you might be caught inside an infinite loop. So a couple examples of loops in Java is the for loop, where you have int I is equal to 0, I is less than 10, I++. Then you're printing out some stuff, and you get an output. The next case is the while loop that's shown in the middle, where we have the same similar thing where we're printing out information. However, within the while loop, we have to increment I, so we're moving closer to I being greater than 10 and exiting out of the loop. Finally, we have a do while loop, where we initialize I to be 0, and then we run one time test, and then we check, is 0 greater than 100? No, so we exit out immediately. If it was 101 is greater than 100, then we'd loop through again. But since we had the condition be initially false, you can see that even though it's initially false, we've run the code at least one time. Now, we touched about arrays in the last class, but to go a little more in detail, we're going to talk about them now. Well, you initialize an array with the class type, open brackets, and then again you can name it whatever you want, and then you set it equal to a new class type where the classes are exactly the same, and then you can specify the number of elements in the array. If you wanted to access a given element, well, you just have to say the array name with the open brackets and the index that you want to access. Do not try to access more than there actually is. So if you define an array of size 3 and you're trying to access the 100th element, that will not work. The next thing is an array cannot be resized. So once you define an array to have 10 elements, it will always have 10 elements. If you wanted to add to that array more than 10 elements, you'd need to create a new array of 11 elements, copy all of the elements in the initial array to the new array with 11 elements, and then you can add an extra thing inside. The last thing to note is arrays always know their size. It's the array.length, and that will give you the size of the array. Now, there are different ways of creating an array in Java, where you can say you have an int array A is equal to the information. Next, int B array is equal to 1, 2, or 3. And notice the curly brackets. Or what you can do is, if you don't have the data right away, you can initialize an empty array, and the default values will be 0, where we have for C, an int array is equal to new int arrays. And then later on, you can initialize them correspondingly. C at position 0 is equal to 1, position 1 is equal to 2, and position 2 is equal to 3. Remember, an explicit size must be given if you want to do this float method. You can't just say new int array, open and close brackets here. It has to have an initial size. Great. So moving on a little bit, let's talk about accessing the elements. Well, as we've previously stated, to access the element, you'd have the name of the array, open bracket, the index you want to use, closing bracket. Each element is stored in a single index, and the indexing begins at 0. So if you initialize it to have a size of 5, it will start with index 0, 1, 2, 3, and 4. And that will have a size of 5 with a max index of 4, since we're starting at position 0. Next, if you attempt to access something outside of the array, as previously stated, you wanted to access the 100th element of a 10 element size array, it will give you index out of bounds. Now, how do you iterate over an array? In the previous class, we went over an example, but to really knock it home, let's have a look at this example here, where we're going through position index 0 up to the length. We have I less than s.length, but you can also have less than or equal to the length minus 1. Those are exactly the same. And then we're incrementing, and then we're just printing out every element in the array. So we're starting at position 0, so it'll be s at position 0, then s at position 1, and so on and so forth. As you can see here, we have string s is equal to different strings for this example, and then that's exactly what we're printing out in the output. Now, if you wanted to resize an array, what you can do is, say we wanted to resize this array here, array A, which has a size of 3. We can create an array called B, which basically has more space than array A. So in this case, we're adding 6. And then we can copy the elements over. So for every element in A, and again, this is a very cool way of doing Python Java for loops, but this is you can use a normal for loop that we've talked about before. So at every position in B, you want to add the variable A at position I, and then you can increment I over and over again. So we've copied every element from A into B, and then we can insert a new element into B, which would be 4, but we couldn't insert it into A because A is completely filled. And then from there, we can remember, it's initialized to 0 by default. So you can see in the output, we've copied over the first 3 elements from A. Then we inserted the 4th element, which is 4, and the other variables have been pre-initialized to 0. Now, to take a step away from that, we're going to talk about object-oriented programming. In Java, you have objects, you have classes, and you have methods. One of the things to note is a class name must match the name of the file. So if you have an object called dog in this example, you'd want to have the class name dog and the file name called dog.java. So a class is somewhat of a blueprint for the objects that are being created. Each object is an instance of a class, and each instance keeps track of its own data. We'll talk a little bit more about this in the next slide. But before we do that, let's look at the example here. We have an object called a dog, where you have to save the name of the dog, its breed, age, and color as different attributes, and then you have the behaviors, which would be bulk, eat, and sleep. So how would this look like programmatically? Well, an object is like a mode, and a class fills the mode. So in this case, we initialize a dog1, which would be something along the lines of dog1 is equal to new dog, and then it would have its own associated breed, age, and color, and it would access the functions or the behaviors bulk, sleep, and eat. Then we can have a completely new dog, which has the same functions but different states or attributes, as well as different dogs could have different states or attributes. However, every dog eats, sleeps, and bulks, so they can have shared methods. Remember, a class is the mode, an object is the mode that's filled in, and methods are the mode that it's made up of, which again, I go through methods as individual functions. So if we go back to our example with the dog is a class. You have a class of dog. The object would be an instantiated dog. Again, dog1, dog2, and dog3. From there, a method would be the eat, sleep, and bulk. Now, moving forward, previously, we went over a simple example using classes, which was using the pizza objects. Each pizza was defined by small, medium, or large, as well as had different topping sizes. So for the default constructor, we set it to be a size of medium with topping of cheese for the default constructor. From there, we had a different constructor which accepted both size and topping. And this is called the parametric constructor. In this case, the constructor took in both the pizza size as well as the topping and set that to be what it was supposed to be. We went over the code previously, but we can show it again here, where you have the default constructor, where it's setting the default size and topping to be medium and cheese. And then the parametric constructor, which took in a size and topping and set that to be what it was. We have setters and getters, or correspondingly accessors or modifiers, which basically return or changes the size and the topping. If you are still interested in this, feel free to check out the previous example that we did. Thank you for your time. Have a nice day.